Good morning. As we start into Chapter 9, we're going to continue our work with quadratic equations and pick up basically where we were in Chapter 8. The two chapters just moved together, and we're going to look at continuing our work with solving quadratic equations. And when we solve quadratic equations, we remember that we are looking for the roots or the zeros of that expression or that equation. We're going to focus in again on the zero product property and how we can use that, and then maybe how we can use some other techniques when we run into some trouble with factoring. So we're going to start with just a quick review. We've got 3 problems here. This is from 911. You could follow along in your ebooks, or you can again have a copy of this document that was attached to the lesson, and you could be writing along in your spiral notebooks as well. So when we go through, we have to use, we want to use the zero product property to solve this. We have to make sure that our quadratic is set equal to 0. And in this first problem, it's not. We should always be checking for that when being told to use the zero product property. So we're going to take this expression or this equation, my apologies, and I'm going to set it equal to 0 by subtracting 9 from both sides. And then I'm going to work to factor this quadratic. Now, this one will probably need the use for some of you of generic rectangles, which is fine. In the interest of time, I'm going to bypass that process, and I'm going to go ahead and just write our 2 factors in. We're going to use 5 and 3. It's going to be 3x minus 5 and x plus 3 as our 2 factors. So here we have it in factored form, and the zero product property would say that we'd take each one of these and set them equal to 0 to find our 2 roots. So 3x equals 5, so x is 5/3. I'm going to leave it like that since it's a repeating decimal, or x is a -3. And there are our solutions to that first quadratic equation. When we go into the next one, now keep in mind, when we're solving this one for A, we're actually finding the 2 values where the output is equal to 9. What that means in terms of the graph is that if I were to graph this equation, y equals 3x squared plus 4x minus 6, if I were to graph that equation, then I would find that at 5/3 and -3, I'd have an output of 9. But we're using this zero product property to find those 2 solutions. I'm going to continue this process with B. In B, the 3 here doesn't really have any impact on the zero product property because it is a constant. There's no variable with it, so there is no way for 3 to become 0. So in this situation, either x minus 5 is going to equal 0, or 2x plus 3 is going to equal 0. So I get x equals 5, or x equals, I would subtract 3 from both sides. I get 2x equals -3, or x equals -3/2. Either one of those numbers are going to make that equation equal to 0. And then in the last one, this one's not in factored form. But when I look at this one, I could go through and I could put a 0 in for C, but I'm just going to look at this and see that they have a common factor of x. So I'm going to factor out an x, and I get x times x plus 6. I know there were some questions last week about situations like this, but essentially what that means, you've got 2 factors. One of them just happens to be x. So I'm going to say x equals 0 or x equals -6, and those would be my 2 solutions. So that's a quick review of the zero product property. So we're going to take a look at this next problem. This next one is x squared minus 6x minus 1 equals 0. It's already set equal to 0, so it seems like it's ready to be to use the zero product property and apply that here. The trouble is, and as Janelle in this problem has suggested, the 0, we can't factor it. Or, I'm sorry, Kira has suggested that. We can't factor this. There are no factors of 1 or -1 that add up to 6. So this one isn't going to go into factored form nicely, and therefore we're not going to be able to come up with our x-intercepts that way. So Kira's saying, well, maybe it doesn't have a solution then. So let's take a quick look. Let's take a quick look at the graph of this equation. I've already typed it into Desmos. I've got the graph. This is the equation here. And clearly, when we graph this, we have x-intercepts. We have 2 x-intercepts. Notice that they're decimals. So there must be a way for us to be able to find that. And I will remind you that last week we spent some time completing the square. So in this situation, we would absolutely be able to find the vertex. We'd be able to find the y-intercept. I'm going to go ahead and put this into graphing form through completing the square and do a quick reminder of that. So if you remember, we want to take that c term and we want to put it to the other side. So I'm going to add 1 to both sides, and I get x squared minus 6x. Now I'm going to add something on to make this a perfect square, and I get 1, and whatever I add on to make this left-hand side a perfect square, I need to add on to the other side as well. I take half of -6. I always look at that term right there. Half of -6 is -3, and I square it, which is 9. So I'm going to add a 9 onto both sides, and I get, in factored form then, x minus 3, the quantity squared, equals 10, and in graphing form, then x minus 3, the quantity squared minus 10, equals 0. That's putting it in graphing form, and that's using completing the square, and that's great. So now I can see that my vertex should be at 3, -10. I'm going to do a quick jump back to my graph here. Clearly, that point is at 3, -10. But again, it still doesn't tell me, these 2 values here. However, I know that if I have this set equal to 0 and I can solve for x, I should be able to do this. I walked through this once last week, so I'm going to walk us through this again very quickly. The first step would be actually backing up to this right here. So maybe I didn't need to go into graphing form when I'm actually solving this. I would have x minus 3, the quantity squared, equals 10. So I can take the square root of both sides, and by doing that, I'm going to work my way in to where this x is. I'm trying to work my way into that variable. And the first thing I need to do here is I need to take the square root of both sides. So on the left-hand side, that's just going to give me x minus 3. But on the right-hand side, it's going to give me both positive and negative square root of 10. And for the moment, I want to just leave it as the square root of 10 because I'm not completely done solving. So this little, right here, this little plus or minus, that plus or minus symbol, ooh, that's a little thin. Let me make that a little thicker. The plus or minus symbol simply means just that. This means plus or minus, or another way to think of it is positive or negative. That means there are 2 values there. There are 2 values there. So I've got plus or minus the square root of 10. I'm going to add 3 to both sides. And I'm going to write it in this form first, and then I'll break it into 2 pieces so you guys see what I'm talking about, because this will connect to what we're doing on Wednesday. So I've got plus or 3 plus or minus the square root of 10. Now what that means is I actually have two values here. I have 3 plus the square root of 10, and I have 3 minus the square root of 10. And in both those situations, if I were to go through and I were to punch those into my calculator, I would get, so the 3 plus the square root of 10 is approximately 6.16, and 3 minus the square root of 10, because the square root of 10 is just over 3. You know, the square root of 9 is a perfect square. The square root of 9 then is 3. The square root of 10 is going to be just over 3 because of that. So this is approximately, it would be 3 minus about 3.16, so it would be negative 0.16. And going back to look at our graph, then you would see those are the values that are actually our x-intercepts. So what we're seeing is that we've got two possibilities for our intercepts. In terms of making sense, you guys are really comfortable with having your solution, and I have this note down here, having your solution as a decimal. So many square roots are not perfect squares. So while there are an infinite number of perfect squares, there are also an infinite number of not perfect squares, and the values that are not perfect squares are way more dense, like there's more of them. So all those numbers that fall between 9 and 16 are not perfect squares. Those are what we call irrational numbers. They're numbers that can't be written as a fraction using integers. So they're decimals, they don't end, they don't repeat, they're just like pi, all of these irrational numbers. So there's going to be two ways that we can represent our values here. One is what we would call, and I have it written down here in the note, it's called the approximate decimal form. And let's just use this as a highlighting example. These values right here are what we would call the approximate decimal form. Whereas, and I'll use, let's use a different color, green. Whereas the numbers here, these are in exact form. Those are exactly the roots. There is no question about it. And that's typically what's called radical form, because you're leaving that square root in that answer. Both are acceptable. It would depend on what they're asking you to find. Sometimes they ask you to find the exact roots. Sometimes they ask you to find the approximate roots. So we're going to go ahead and we're going to practice this again. This idea is using completing the square to solve for x. I have two more examples on this page. So looking at this first one here, I would have to work towards completing the square. So my first step would be that I am going to add 3 to both sides. And now completing the square can be used here without putting it equal to 0 first. And you guys are going to see that in a second. I'm going to make this plus blank because I know I'm going to add something on there. Equals 1 plus 3 is 4 plus something. I take half of negative 2. Remember, it's half of that middle term. So half of negative 2 is negative 1, and square it. So it'd be plus 1, and I need to add 1 to the other side as well. At that point, I'm going to have a perfect square on the left-hand side, x minus 1, the quantity squared, equals 5. And again, so now technically, I've completed the square. I could subtract 5 from both sides, and I could have that into graphing form. But all I'm asked to do at this point is to complete the square, and that's what happened right here. This piece right here is what we call completing the square. And now I'm going to continue to solve in the same way that I did on the other page. So I'm going to take the square root of both sides. Square root here, square root here. So now I have x minus 1 is equal to the positive. Let's clean that up a little bit. Sorry about that. Is equal to the positive or the negative square root of 5, because we know there are two roots when we take the square root of something. And then we're going to add 1 to both sides. And I will tell you that it will always be put in front of the radical, because if we don't put it in front, then the problem is that it looks like it could fall under the square root. So I'm going to put my answers over here just because I've got another problem right underneath it. So one solution would be 1 plus the square root of 5, which is approximately, again, when you use your calculator, that is approximately 3.24. Or I'd have 1 minus the square root of 5, and this is going to be a negative value because the square root of 5 is just over 2. If you guys remember that, square root of 4 is 2, so the square root of 5 is going to be just over 2. So this becomes negative 1.25. So there are my two two values for x, solving for x in both decimal form and in radical form. So now we're going to take a look at the next problem. I'm going to go through the same thing. Now, here's the catch. The catch is right here. I want my lead value to do completing the square. It's so much easier if that lead value of x is just 1. So we can do that. And just bear with me here for a second. I'm going to go ahead and I'm going to divide everything. I'm going to divide everything by 8, both sides. And when I do that, when I divide both sides by 8, I get x squared plus 5x equals 29.75. Now, at this point, it really doesn't matter what's on the right-hand side. The catch is that, oh, I forgot to put my pluses in. I'll do that now. So I'm going to have x squared plus 5x plus blank equals 29.75 plus blank. So the catch is that I can make this a perfect square trinomial over here on this side by finding half of 5, which is 2.5, and squaring it. So I'm going to add 2.5 squared, I believe, is 6.25. Yep, 6.25. So I'm going to fix that. 6.25. And then I'm going to add 6.25. And fortunately for us, this is working out really nice. So this becomes x plus 2.5, the quantity squared, equals, these two add together and give me 36. Even better, because now when I take the square root of both sides, 36 is a perfect square. So I'm going to get x plus 2.5 is going to equal plus or minus 6, because the square root of 36 is both positive 6 and negative 6. And then I'm going to subtract 2.5 from both sides. And again, I personally would write this as negative 2.5 plus or minus 6, giving me then my two solutions, negative 2.5 plus 6, which is the 3.5. Let's back up and write that out, what I'm doing, so you guys can see it. So I have negative 2.5 plus 6, which equals 3.5, or negative 2.5 minus 6, which equals negative 8.5. So we have our two solutions for that equation as well. So this is the idea of going through the process of using completing the square to help find our solutions to x, because then you can take the square root of both sides and move on to find both the positive and negative values of the square root and find our two intercepts. All right, so your homework to go along with this assignment is 9-6. In 9-6, they're going to have you walk through the same thing for 4 different problems. You're going to be completing the square and coming up with the solutions just to practice this skill alone. Remember, if you have any questions, to reach out to either myself, Mrs. Craven, or to Mrs. Huckel if